So here we have a couple more exercises, and what's different here is that our given is saying angle FGJ, right, is congruent with angle JGK. So this is saying the angle in the figure is congruent with the other angle in the figure, right? Same thing here. And so when we go ahead and write down our statements, right, we want to start with what's given, which are our congruency statements. And then our first move is going to be to take it from congruency to equals, right? Oh, I'm sorry. These are also given here, right? These measure of angle FGJ, this is given. But our first statement after the given is going to be to take these congruency statements and to change them to equal signs. So we're going to say the measure of angle FGJ is equal to the measure of angle JGK, right? And we're going to do the same thing with this congruency statement as well. And then we're going to use our algebraic properties and substitution and subtraction and whatnot to finally get to our proof or statement, which is down here. All right. So angles, we're going to convert from congruency statements to equal signs, right? But remember, when you do, you have to say measure of angle, right? Measure of angle. And then over here, we're going to do the same thing. This is our last exercise. And notice here, we start with our given, which is a congruency statement. And our first step is to change it to an equal sign involving the measure of the angles. And then we use our algebraic properties to get to our final step. And one new reason that we're going to need for exercise number 13 is to be able to say a measure of angle RTD is equal to measure of angle STC, right? So angle 2 is equal to angle 3. And how are we able to say that angle 2 is equal to angle 3? Well, there's a theorem. It's vertical angles are congruent. And so we learned about that a couple chapters back, and it's coming back, right? So that's going to help us in our proof here, is that angle 2 is equal to angle 3, measure of angle 2 is equal to measure of angle 3, because vertical angles are congruent. Right? And we're going to do the same thing with A and angle BST. Vertical angles are congruent. This is going to be our reason, right? So a new reason. And then we can get to our proof using the substitution property.